Hello everyone, welcome back to System Shogun. I want to talk about something that I've been observing for the past few months, both in my projects and online, on LinkedIn, watching YouTube videos, and it got me thinking that there has to be a way to at least give guidance to people about this issue and how to solve it. So I started looking at a framework or let's say philosophy that helps with this problem, and I did something and I tested it at work. I integrated it at into my own project, and it seems to work and it seems to be pretty good. So I spent the last month formulating it and creating this framework so that this could be potentially useful to everyone out there that is having the same issue. And what is the issue that I'm talking about? Well, it's AI. The issue with AI these days is that everyone is using AI for everything, and that's great. I love AI, I love this technology, I use it all the time. The issue comes when you start using AI in your projects without having any guardrails. Without this, AI is doing more harm than good. And what do I mean by that? Well, once you start a project, once the developers start using AI, usually they're using AI as an assistant. So they have a feature that they need to implement, and what they do is they simply put a prompt saying, please create this endpoint or please create this UI, and that's it, which is kind of bad because in time you are making your code base a complete nightmare for you and everyone else. AI will help you, yes, it will create your feature, but while doing it, it will not follow any patterns that you've created, it will not follow your structure, your intent. It will do it, but in its own way. And this is bad because once you create a structure, once you build your architecture, you don't want people or AI to mess around with it, to go around it, to skip it. You want the architecture of your solution to be this castle, this big castle that no one can go around. And you want your solutions to be well architected and AI native. What do I mean by that, AI native? Well, by AI native, I mean that you use AI, but the AI itself knows about how your project is structured, it knows about the architecture. So when it starts working, it works in the context of your design. It follows your rules and it's not going around them. So you have this big castle, this huge big castle that you've built through time, through discussions with the business, through following requirements, both functional and non-functional. You want this to be followed by everyone. And this issue is everywhere nowadays. Everyone is using AI as an assistant, which I guess by now you know it's a terrible idea. And now we have tons of projects that are basically gone. You need to throw them in the bin and start all over because people were using AI for everything, and AI made everything worse, and AI made your code base worse, and now neither human nor AI can keep adding features because it became a mess. So anyways, that's the issue, and I'll present to you today something that I call protected AI native or pain architecture. Why pain? Because if you're not following this, you feel up the pain. Maybe not today, maybe not tomorrow, but in 3, 6 months, maybe a year, your project will become a mess and no one can save you. So let's talk about this pain architecture. On the left, we start with the AI accelerated architecture phase. Let's zoom in and take a look at it. So this is the starting phase. This is before you start development. You need to have a good, sound, AI accelerated architecture. So when you start, you as an architect start working with, of course, agents on your side. You need to use AI because AI is really powerful in the right hands and with the right use. So you start with AI-powered IDE like VS Code, and you start using AI. And there is a loop here. So both you as an architect and AI start designing the architecture. And that architecture is based on meetings with the business, reading and following functional and non-functional requirements, adjusting to all the things that your solution needs to follow, all the rules, all the requirements, hundreds of discussions, you know the drill. So all that is in here. So you use AI and your own judgment based on the discussions to build the protected AI native architecture. And here is the artifact on the right. So you first start with architecture styles and patterns. And as you can see, the build order is from the bottom to the top. And on the top, you see the last bit, and you see on the right, it says knows about. So each layer here knows about every layer below it. And you see how this helps in a bit. So you start with the architecture styles and patterns. You define those based on the requirements and the use case that you solve through software. Then, once you have that, of course, you need to build architecture tests, which will help with keeping your architecture intact. Then, we continue with architecture documentation. Of course, you need to document your architecture, both for humans and AI. And the last bit is extremely important. And as you can see, it's at the top of the pyramid. So what this means is that architecture guardrails knows about documentation, tests, styles, and patterns. And you see how powerful this is. Now, let's zoom in a bit. So here is a bit of a detailed version here. So this is the architecture phase, but with more details. So first, here is the architecture styles and patterns. Here you have like all the things like event-driven architecture, vertical slices, domain-driven design, CQRS, clean architecture, modular monoliths, microservices, layered architecture, you name it. Based on your use case, based on your requirements, you, of course, decide what architecture styles and patterns you need to use. Then, architecture tests, libraries like ArcUnit.net, for example, or depending on your programming language. Then, architecture documentation. These are, for example, ADRs, so architecture decision records, guides, conventions, like naming conventions, code conventions, onboarding guides. Everything needs to be documented. And then we have the architecture guardrails. So things like instructions, subagents, skills, hooks, prompts, and everything else that comes from now on. And as part of the architecture guardrails, we have the pull request guardrail, which needs to have both the agent and the human as a reviewer. First, the agent reviews your code, then human reviews and approves it. Okay, now once you have all that, it's time to start developing your solution. Let's take a look back at this diagram here, and let's go a bit on the right. And as you can see, now we have the architecture done, so development phase begins. Let's zoom in. And again, we have an AI-powered IDE and a dev team that consists of humans and AI. What your dev team does is they do development, right? So the next phase is AI accelerated development. So in here, both your developers, like human developers, and your AI agents write code in a loop until they build their feature. Once that's done, we have the pull request governance, where, if you remember, you need to have both AI agents and humans as reviewers. But first, the reviewer needs to be the AI agent. So the AI agent scans the code, checks it if it's okay based on our protected AI native architecture guardrails here. As you can see, everything sits on top of it now. So the AI agent checks everything if it's okay and if it's compliant to the protected AI native architecture. If all is good, then next reviewer is the human. We always need to have human in the loop. AI agents are non-deterministic, so you cannot trust them 100%. There always need to be human in the loop. Now, a human developer checks the code, makes sure it's okay. If it's okay, then we approve the continuous integration step in which we have tests and code scans. Absolutely important. So we have the tests for example, the ones that come from the pane architecture can be here. Maybe other tests can be added here. And the extremely important bit here is code scans, because you never know if something that AI wrote, or even a human, is okay. But especially AI, you cannot trust AI's code without review. So code scans, absolutely mandatory. If all that is good, then and only then we push the code into the repository. And this repository I call protected AI native codebase. So it's protected by guardrails, it's AI native by design. And what do I mean by that? So your architecture now supports agents in such a way that agents can be part of your dev team. They understand your code base and they follow the rules that you as an architect enforced. They follow your architecture. When you have the pane architecture ready and done correctly, you can build features faster because the AI agents are following your rules and they implement features in such a way that it keeps your code base clean, safe, maintainable. And of course, we have governed by AI and humans, which is extremely important. Whenever you use AI, you need to have governance that is both implemented by AI and humans. Okay, now that you know what is pane architecture in a nutshell, let's take a look at a quick code example that I built just for demo purposes. So now I'm inside VS Code. As you can see here, we have .github. If we go there, you see I have agents, hooks, instructions, prompts, skills, and workflows. I also have Copilot instructions. We also have docs here where we put our documentation. Now, let's go over each one of these. Let's start with agents. So I've created a few agents here that are orchestrated by the backend agent. Let's go to the backend agent here. Its role is to orchestrate feature implementation by coordinating draft, review, documentation, and test agents in sequence. Here we have the tools that this agent is allowed to use and the agents that it can call. We have some description about the agent and information that the agent needs to have in order for it to work correctly. We have of course, these other agents: documentation agent, draft agent, review agent, test agent. We have an architecture agent, which understands the code base and acts as an architect. And that's agents. We have hooks, which is extremely important piece. So hooks work as in React hooks or any other hook. Basically, you can trigger them whenever some event happens. For example, we have protect files hook, which forbids the AI from touching any of these files. And if you think about it, this is great because once you build your architecture, you don't want your AI agents to mess around with your architecture. Once it's defined, it's done. If you want to change it, there are other ways to do it, but directly, AI shouldn't change your architecture designs. Of course, we have block dangerous commands here, and this hook prevents using some of these dangerous commands like drop. We have instructions for the agents. So, for example, if we go here, we have API design instructions. So whenever we need to do some API design, we can put the rules here. So they need to follow these rules. If we go under documentation, same thing: error handling, security, performance, testing. We have prompts. For example, I have only one prompt, which checks the CS profile for forbidden project references. And for example, let's test it. We can test it by doing this. And as you can see, here is the prompt. And let's see what happens. So instead of always writing the same prompt, you can save prompts in here and reuse them. And great, no violations found. That's what we want. And skills. Skills are extremely important. Skills basically are like prompts that you can reuse, and they give special skills to your AI agents. You can actually tell the AI agent how exactly you want things to happen. For example, you have coding standards skill. Whenever your AI agents start coding, they, first of all, every agent reads this metadata every time they start working. So for every skill, they read the metadata automatically and decide at runtime if they want to use any particular skill. So whenever they start working on C# features, they will read this and they will follow what you wrote in here. So you need to spend some time to make sure that you design these in a good way. Now, Copilot instructions, every time AI starts working, it automatically reads this file. So in this case, I'm saying that it needs to follow these architecture rules in this document, the coding standards in here, and the naming conventions in here, that all the code must pass architecture tests in here. And here are the subagents and what each subagent does. And that's the Copilot instructions. So let's take a quick look at the docs. So for example, here is the architecture documentation. It explains the project and it gives some rules that need to be followed. We have code conventions and we have naming conventions. So extremely important, always document your architecture. Let's take a look how this makes our architecture PAIN architecture. So protected AI native architecture. So now let's use the backend agent to implement a feature. Here is the backend agent. And remember that this agent orchestrates the feature implementation. But now I'll try to mess things up. So let's ask this agent to implement a feature in the wrong way. Okay. So I'll ask the agent to develop a feature, get weather station by ID. So I'm saying that I was thinking of adding a weather station service under source domain services to keep things simple, which is wrong. We have an architecture and this putting the service inside the domain is wrong according to our architecture. Let's see what happens. So it starts loading skills and documents, all the rules here. So as you can see here, it knows that this is wrong, and it violates the conventions. And instead of following what I asked, it follows the conventions that are part of our architecture. So it will put this inside a use case and not inside the domain. So then it asks the draft agent to make a draft here. Then we go to the review agent here, and the review agent will check the solution, if it's compliant or not, to our architecture. Okay, review passed. We are moving to the test agent. So it will perform some tests. As you can see, it's reading the test patterns that we have, so it makes sure that it's following them. So like I said, documenting everything is extremely important in this AI era. Okay, tests have passed, all good. So we are moving to the documentation agent to document the feature. So as you can see, we have the full lifecycle. We start with the backend agent that checks what needs to be done. It writes the requirements. The draft agent builds the draft. Then we have the test agent to test the solution. We have the review agent to review the solution. And we have a documentation agent that documents the solution. And all that sits on top of our PAIN architecture. All the rules, all the guardrails, everything. So we have the final verification and we have the summary of the changes. Okay, and that's great. As you can see, using AI like that saves us from trouble. and we have the full life cycle of a feature implementation. Great. Okay, we saw how we can implement this in code. Now I'll show you quickly pull requests and this bit right here in a nutshell. If we go to pull requests, here I tried to implement a feature that contains security issues. And we have a code security triggered, which is Git Guardian. And this notified us that whatever we are deploying contains security issues. And the security issues are hard-coded secrets. Great. And we have the Copilot leaving comments as well, saying that whatever we're doing is not okay. So we wait for the AI to do the hard work and then we review. And we see, it's easy to see that there are tons of problems with this pull request, so we're not merging it. And here's another one. Here we don't have coding issues, secrets anymore, but we still have issues with the code. So we're using the Copilot code review agent, and it's again telling us that things are not done properly. So we as humans cancel the pull request and ask the developer to fix those issues before we let this code into our repository. And this is how we can implement this step right here. And yeah, I mean, that's it in a nutshell. That's the pain architecture. All this is based on my own experience, and I'm implementing these things in my own projects. And I think that more and more people need to start following this or something similar to this sooner rather than later, because, like I said, using AI as a coding assistant in your projects is a terrible idea. The most important part of this video is the idea that once you let AI write code in your projects, write features, you need to know what this means for your project. If there are no guardrails, if you're just using AI as a coding assistant, sooner rather than later, your solution will become a nightmare. Thanks so much for watching this, and I'll see you again next time.